My dear students of BTech second year, I am Dr. Ravin Parsai, Associate Professor of Mathematics in Engineering Science and Humanity Department at Jamil Devi Group of Institution Indore. I wish to teach you through Lecture 4, Solution of Simultaneous Linear Algebraic Equation by Crowd's Method with example. So first of all, we understand the process of Crowd's method. It is to be designed by a very famous scientist Crowd, so that it is called Crowd's method. So let us consider a system of equation in three unknowns. One is x1, another is x2, and another third one is x3. Say by their coefficient. So now our duty is to first we reduce in to write any system of equation into this standard form, just like to the previous one. All unknown terms left side and known value as constant term on the right hand side of the equation. And now we write the augmented matrix of the given system of equation. You know that how can we write an augmented matrix very well. You have studied through first year level. So AB is A and B both are combined whenever a coefficient matrix is combined with constant matrix, so that this type of matrix we called as augmented matrix. So A11, A12, A13 of B1, A21, A22, A23 of B2. Third one equation taking the coefficients A31, A32, A33 and B3. Now from the above matrix, the matrix of 12 unknowns, so called derived matrix और ऑक्सिलरी मैट्रिक्स. अब हम क्या करेंगे, इस ऑगमेंटेड मैट्रिक्स की हेल्प से एक नया मैट्रिक्स डिजाइन करेंगे. उसका भी ऑर्डर यही सेम होगा, मतलब उसमें भी इतने नोन वैल्यूज हैं. तो अपने पास 12 कितने हैं 12, इसमें 12 अननोन्स वाला हम लोग एक मैट्रिक्स को डिराइव करेंगे. इसलिए इस नए मैट्रिक्स का नाम डिराइव मैट्रिक्स होता है. कुछ ऑथर्स इसको ऑक्सिलरी मैट्रिक्स भी बोलते हैं, और इस मैट्रिक्स को डिनोट करने का स्टाइल है D/M. ओके, एंड इज कैलकुलेटेड एज फॉलोज. अब हम ये जो वैल्यूज हैं, ये जो मैट्रिक्स के अननोन्स हैं, उनको एस्टिमेट करने का एक फिक्स सेट प्रोसीजर है, जिसको हम लोग स्टेप बाय स्टेप बताने जा रहे हैं नेक्स्ट स्लाइड में. सबसे पहले हमारी स्टेप 1 आएगी. द फर्स्ट कॉलम ऑफ द डिराइव्ड मैट्रिक्स इज आइडेंटिकल विद द फर्स्ट कॉलम ऑफ द ऑगमेंटेड मैट्रिक्स. Then the second step is the first row to the right of the first column of the derived matrix is obtained by dividing the corresponding element in augmented matrix by the leading diagonal element of that row. Then in step number 3, the remaining second column of DM is calculated as follows by using this formula. L22 minus A22 minus L21 of U12 L32 are equal to A32 minus L31 of U12. Then we come to step number 4. Remaining element of second row of derived matrix is calculated as follows. Since you have calculated the leading diagonal element of this row, that's why you divide this difference value by the leading diagonal here. So that is U23 formula is A23 is corresponding element minus L21 into U13 divided by this leading diagonal. Similarly, this is also of this second row, so leading diagonal is L22, so you also divide by L22, B2 minus L21 Y1 upon L22. So the remaining element of third column of derived matrix is calculated as follows. L33 equal to A33 minus L31 U13 plus L32 of U23. So now in this sixth step, the remaining element of the third row of derived matrix is calculated as follows. Y3 equal to B3 minus of L31 Y1 plus L32 of Y2 upon L33. Hence from the above derived matrix, the required solution is to be obtained also in a standard pattern. As for calculating the value of the third unknown, that the last unknown is the value is this value always match with this. You have to equate with this. X3 equal to Y3. While x2 is calculated by y2 minus 2 u3 of x3, and while x1 is calculated as by corresponding element y1 minus difference of this value is taken minus common, so x2 of u12 plus x3 of u13. So let me explain this method by an example, or this method can be understood by an example here. So sometime method is mentioned, sometime method is not mentioned. Let us suppose that the method is mentioned. Apply Kraut's method to solve the equations. This is the system equation already set up in standard form. All unknown values are left side and known values on the right hand side. So first of all, you write down the augmented matrix of from the given system equation is, let me suppose that arbitrarily these values are a11, a12, a13 or b1, while these values are already known to you. A11 means 2, a12 is minus 6, a13 is 8, then b1 is 24. Like this, you can give these names here. Now from the above matrix, the matrix 12 unknowns, so that called derived matrix or auxiliary matrix is obtained or is to be calculated as follows. In the first step, the first column of the derived matrix is identical with the first column of the augmented matrix, that is L11 equal to A11. A11 की वैल्यू है आपकी 2, L21 की वैल्यू है A21 equal to 5, L31 की आपके पास वैल्यू है A31 है, that is equal to 3. Then you come to the step number 2 as the first row to the right hand of the first column of the derived matrix is obtained by dividing the corresponding element by the leading diagonal element of that row. That is, we recall this formula by an example here. U12 equal to A21, A12 is corresponding element divided by this leading diagonal is already calculated of this row. So divide by this, so minus 6 upon 2 is minus 3. Then similarly u1, 2 and 3 formula is a corresponding element is a 1 3 divided by leading diagonal, so that is the value is 8 upon 2 is 4. Then y is equal to b1 upon a11 equal to 24 upon 2 is equal to 12. Step number 3, you come to remaining second column of the derived matrix is calculated as follows. L22 equal to A22 minus L21 of U12, as the formula I have been already explained you. 4 minus 5 into minus 3, the value is 19. L32 is A32 minus L31 of U12 equal to 1 minus 3 of minus 3 equal to 10. So we come to step number 4 as remaining elements of the second row of derived matrix is calculated as follows. By explaining to you already the formula here, A23 minus L21 of U13 upon L22, that is minus 3 minus 5 of 4 upon 19. The difference of this value divided by 19 is minus 23 upon 19, while Y2 is equal to B2 minus 2 21 of y1 upon L22 equal to 2 minus 5 12 upon 19 equal to minus 58 upon 19. So the remaining element of the third column of derived matrix is calculated as follows. By formula already explaining to you, A33 minus L31 of U13 plus L32 of U23, that's this value is this, and then by simplifying algebraically this value is 40 upon 19. Then we come to the step number 6 as remaining element of the third row is calculated as follows. Y3 is equal to this formula, B3 of this, and equal to this much value is after simplification equal to 5. Hence from the above derived matrix the required solution is obtained as follows. X3 equal to Y3 equal to 5, while X2 equal to Y2 minus U23 of X3 equal to this 2, while X1 equal to 1. Thank you very much.